Next, we will first look at the required components to support the 50mm EDF unit that would go into this 70mm lightweight airframe. On the left-hand side, you will see cups of two cup sizes. The white cup has an overall outer shroud of 70mm, which fits perfectly inside the hull of the airframe. For illustrative purposes, the brown cup has an outer shroud diameter of 80mm, which is way too big for the airframe, and we won't be using this cup. If you look at the lower picture on the right hand side, you can see an idea of how the actual EDF unit in its thrust tube cone fits against the white and brown cup. On the bottom left hand corner of the screen, you need a cone that has 55mm outer lip for the leading edge of the cone and 45mm exit port for the trailing edge of the EDF cone. The ratio will give an 81% ratio, which in my experience optimizes the EDF thrust tube efficiency, thereby maximizing the EDF unit's propulsion and performance. This is like pinching your garden hose so the opening of the hose is small enough such that water exits the hose with the highest pressure while moving the maximum amount of water through the hose. The EDF thrust tube is working exactly the same way by moving maximum amount of air through the 45mm port and maximizing the EDF unit's performance.